And then I was approached by somebody else to do something completely different, and this resulted in another kind of invention. This device here is a combination stretcher and scoop stretcher. It actually, if you're in an accident, God forbid you ever see this thing, the device at the top is existing now. It's kind of like a metal spatula. And the device at the bottom also exists, but the problem with a lot of injury cases is that when an emergency service worker picks somebody up and puts them on a backboard, they actually cause more damage to the person's vertebra and potential spine injury if they log roll them or lift them. And so my client wanted something that did both. And the problem is that you can't do that with plastic. It's very difficult. And so the challenge was to come up with some sort of structure and some combination of elements that would make it satisfy that very demanding load, which it had to be. It had to support about 400 pounds. So lots of experimentation, lots of foam mock-ups. I'm sure you guys are familiar with doing that sort of thing. I heard some talk about foam core models. The other thing that had to be, since it was not going to be made out of metal, it would then be X-ray lucent. So that if you took this person directly from the ambulance into the MRI device, then there wouldn't be any type of magnetic interference or metal interference. And it wouldn't interfere with some of the imaging also. So anyway, this is the second generation that I'm showing you here. The first generation was the turquoise version, but the next one was thinner and smaller, and all of this was achieved by using carbon fiber as one of the things that was actually centered within the handles, which was a pretty big engineering challenge. And you can see that orange thing is the carbon fiber. But to get all of that to work using rotomolding, which is takes a big tool like this, puts it on a platform, and then puts it in a giant oven and rotates it in two different directions. And to have all of that come together and to get a pretty good part is a real big challenge. So here you can see that it is supporting at least 450 pounds. This is another project that was also very good. And it resulted from actually working on a device at Patton, which was a blow molded. It's the same process that you used to make bottles with. Thinking maybe if I can apply that process to this combination of things, I can make a helmet. And before, my client had a thing that they glued together with different plastic parts, and it was very kludgy, and it turned out that by applying this production process, I could get one unitized, very lightweight, very highly structural piece that would satisfy all of those conditions. And it was for surgery. This thing actually has a fan that blows air over the top of the surgeon's head and down across their face, and creates a positive air pressure so that airborne particles like HIV and benzene and some of the things that occur when people are being cauterized, the flames are coming up through their nostrils. It actually pumps that air out. So there is actually a surgical helmet industry. So this was actually pretty revolutionary because it sort of took the model of a bicycle helmet and applied it to a surgical device, and it really was a hit for the company. They ended up taking the top market share for such a product. And the thought was, if you can sell a bicycle helmet for $50, why can't a $2,000 product at least be half as good as that? So you sort of compare things. And like the iPod, I was talking to you about, why can't some medical apparatus be at least as nice as everyday electronics? So these are some other projects I've worked on, some stuff for Toshiba. This is kind of old looking now, but it was at the time it was one of the first flat screen devices. Some laptops. More recently, some memory sticks that resulted in these travel drives. This was a collaboration with another local designer. Some other hard drives. And some mice for Gateway. You know, lots of different foam mock-ups to find the right fit and feel. And this is actually another interesting thing. I was driving around looking for a client in my area, and I did come across a company called BioBase. And it turns out that they were using another designer, but I said, you know, if you ever need something done locally, I would love to help out. And so he said, the guy said, well, I'll try you out on this mechanical arm. And it wasn't a very exciting project, but it allowed me to at least gain their confidence and get one success in there so that they might invite me to do something else. And the next thing they invited me to do was to finish this other project. And it's odd, the mud flap lady there, I put that on there for a reason. And that they were going in the direction that this is an $80,000 device for using a laser to actually carve teeth instead of a drill. So it's a very high-tech piece of equipment, and they wanted to really make this a splashy design. And their approach was to actually make it sexy and to imply you know, a female body in the vent pattern on the side, at the same time light it up like a Christmas tree. And so I thought, no, you know, I can't let this happen. Because, and I did mention the chrome mud flap lady. I said, this is really going tacky. Maybe if we can just translate that motivation into something a little more subliminal, you know, maybe, you know, and I said, don't even do that. But they said, we must have this thing because we have to make this a sexy, sensuous device. So, even though it's used for drilling teeth. So the best I could do was to maybe just put in a sweeping curve that was ambiguous, so it wouldn't necessarily be what they thought it was, and I could live with it. And so it resulted in that, and that sort of became a visual motif for this. And you can sort of see that swoopy line just for the part that holds the handpiece. But that's how things mutate, and that's how you sort of say, okay, I'm going to create a family look, I'm going to create a visual language that I can carry over to a certain product line and apply a certain consistency. And I'm sure that that's one of the challenges that you probably have in your design classes, to create a family look. So it started out